Now we are learning the hypothesis testing for one population mean when the population standard deviation sigma is unknown and we are still using a p-value method, right? So before I even tell you what are those steps, it is important that we pay some attention toward the situation when the population standard deviation is unknown. So far we have taken the examples in which the population standard deviation was known, and remember that was a less realistic situation. What happened? Sigma is usually unknown. Now we are going to discuss this a little more, what I mean by that. Now what I'm saying that I'm talking about a situation when sigma is unknown, right? That's what I'm trying to say. Sigma is unknown. What happened? So the question that comes to the mind is this really what happens? The sigma is usually unknown. The answer is yes. In most practical situations, in most real life situations, the population standard deviation is usually unknown, right? And what is the reason for that? What is the reason why this happens? Why the population standard deviation is unknown? The reason is we calculate sigma, we calculate population standard deviation from the population mean. From the population mean. In order to calculate sigma, we need to know population mean. And what happened in many practical situations, the population mean is unknown. So if you don't know the population mean, how do you know the population standard deviation, right? So this is very important that we understand this situation, that the sigma is usually unknown in many practical situations. And why it is unknown? Because in order to calculate population standard deviation, you need to know population mean. And in many practical situations, you don't know the population mean. Why? Why you don't know population mean? Because in the real life situation, you don't have access to the entire population, right? You don't have resources. You can't access the entire population, and that is why you are doing the sampling, right? That's why you are doing the sampling in the first place. So this is very important what we understand this scenario, that why and when the population standard deviation is unknown. So after discussing this this scenario, why the sigma is unknown and in which situation it will be unknown, now let's see what are those steps. In the first step, we check the basic requirements, and we have here two requirements. Number one, the populations, we have to have a simple random sample. These two conditions looks familiar, right? You need to have a simple random sample, and number two, either the sample size is greater than 30 or the population is normally distributed. And recall, this condition will guarantee that our sampling distribution will be normally distributed, right? That either the sample size is greater than 30 or the population is normally distributed. For the second step, in the second step, what we do, we state the null hypothesis, we state the alternative hypothesis, we decide the type of test, and we determine what is the level of significance. Third step. In the third step, we find the value of the test statistic, right? And for this purpose, we use this formula, which is T equal to x bar minus mu divided by S, or the sample standard deviation, the square root of sample size. Now let's see from where this formula come into existence. Now, what happened? We don't know the population standard deviation. Yeah, we don't know. What we do, we approximate this population standard deviation by the sample standard deviation, right? That's what we do. And as a result, the sampling distribution, which is given by this formula previously, what we do now, we replace this population standard deviation by a sample standard deviation, and the resulting formula is like this: S over the square root of the sample size, right? And this resulting distribution, this is a new distribution which is called a student t distribution. We already have discussed what is the student t distribution and how it looked like, and we have seen in chapter number 8 what are the properties of that, right? I repeat this once again. When we don't know the population standard deviation, we approximate with a sample standard deviation. So what we do, we replace this sigma by a sample standard deviation, and the resulting distribution, the sampling distribution, now follow a new distribution which is called a student t distribution, right? So that's what we do. This I already told you. In the next step, what we do, we find the p-value, right? We find the p-value and we use Excel formula t.dist, and what we provide the t-test statistic, which we have calculated from here. We provide the degrees of freedom, and recall from the degrees of freedom is always equal to sample size minus 1, and we provide a Boolean variable. Are you looking for the cumulative area all the way from the left to the up to the boundary wall of the test statistics? And usually we say yes or a true here. This is the Excel formula, and you will really know when I take a real example, right? You will really understand this formula when I give you the real example and I demonstrate this in Excel. What is the last step? In the last step, we compare the p-value with alpha. If p-value is less than alpha, then we reject the null hypothesis. Recall once again, if the p-value is low, H0 has to go, right? If the p-value is greater than alpha, then we fail to reject the null hypothesis, and we also try to interpret the result of the hypothesis testing. So these were the 5 steps for performing a hypothesis test for one population mean when the sigma is unknown. Now what I'm going to do, I'm going to take a real example and I demonstrate how this works. Let's see an example. Now let's see an example here. Suppose a can of soda is supposed to contain 12 ounces of soda. A random sample of 10 cans taken by the state of Washington yields a mean of 11.9 and sample standard deviation of 0.2 ounces. For alpha equals to 0.01, the 1% significance level, should the state conclude that the soda cans are underfilled? What p-value would you report? Assume the ounces of soda in a can follow a normal random variable. Use p-value method. So we are given this problem and we are asked to perform a hypothesis test. And recall, we want to perform a hypothesis test for one population mean when the population standard deviation is unknown. This is the standard deviation, but this is the sample standard deviation. This is very important that you realize this, right? So let's recall what are the steps we have. How many steps we have? Recall there are 5 steps. So we will perform these steps one by one. Step number 1. What was the first step? In the first step, what we do, we check the basic requirement. So let's write basic requirements. What were the basic requirement? Number 1, we have to have a random sample. And number 2, either the sample size is greater than 30 or the population is normally distributed. So these were the 2 basic requirements, right? So the state collected a sample, a random sample. Look at that, a random sample. A state took a sample and that was a random sample. The first condition is good. We are good with the first condition. Now look at the second condition. Assume ounces of soda. Look at what is written. Assume the ounces of soda in a can follow a normal random variable. So we are given the population is normally distributed. Look at the sample size. The sample size was equal to 10, and that is definitely less than 30, right? The sample size is less than 30. But what happened? This condition was not met, but the second condition met. Remember, either one of the conditions should met for in order to this step to be okay. So our population follow a normal distribution. So both the basic condition are met. So we are good with the first step. Now we move to the step number 2. So let's write the step number 2. What is the step number 2? In step number 2, we decide the confidence step number 2. We decide the null hypothesis, the alternative hypothesis, the type of test, and the significance level. So what is the claim? Let's write the claim. The claim is the state think that these cans are underfilled. So what is the claim? The claim is we want to feed the mean. If we want to prove that this is less than 12 ounces, right? That's a claim. The mean amount of soda is less than 12 ounces. And what is the opposite of that claim? Let's write the opposite of that claim. The opposite of that claim is mu, the mean is greater than or equal to 12. Remember, if we have a symbol less than, its opposite is always greater than or equal. Now recall one of these statements is a null hypothesis and the other one is an alternative hypothesis. Now recall from our earlier discussion, a null hypothesis never contain a less than symbol. It never contain a less than symbol. So this must be an alternative hypothesis. It's sub A, and that it says mean is less than 12 ounces. And if this is an alternative hypothesis, this must be our null hypothesis. It's sub 0. And what we are going to do, we are going to drop this greater than sign and we're going to just take an equality. Why? Because the null hypothesis is always a statement of equality. The null hypothesis is always a statement of equality, right? So now note that what we note that the alternative hypothesis contain a less than symbol, right? It has a less than symbol. We note that H sub A contains a less than symbol. So this implies that it's a left tail test. Left tail test. L for less, it's an easy way to remember. L for less and L for left, right? That's an easier way to remember that. And finally now, what we are going to do, we're going to decide the significance level. It has given to us the level, the significance level is 1%, sorry, 0.1. Here it is, the 1% significance level. Look at that, 1% significance. So what we have done, we have completed the step number 2. We have our null hypothesis, we have our alternative hypothesis, we know what type of test it is, it's a left tail test, and we have determined what is the significance level, right? So now what we are going to do, we're going to move to the step number 3. Let's see. So now we are in step 3, and what we do in step number 3, we find the value of the test statistic, right? So let's see, and fortunately we have the formula for this. This T equals to x bar minus mu divided by S over the square root of the sample size, right? This is the formula, and recall from my earlier discussion that this is a T test statistics. This is called a T test statistics instead of Z test statistics. Why? Because we don't know the population standard deviation, and we are approximating the population standard deviation by a sample standard deviation, and the resulting distribution is a T distribution rather a Z distribution. So what we do now, we plug in the values here. We have all the values available. It's 11.9 minus 12 divided by 0.2 over the square root of the sample size. Now we simplify this. 11.9 minus 12 is minus 0.1, and now I write this in a simplified way. Keep it, change it, flip it to make our life easy. Divide by the 0.2, and when I plug in all these values, the answer comes out to be minus 1.58. This is the value of the test statistics that comes out, minus 1.58. So we are able to find the value of the test statistics. So we have completed the step number 3. Now let's see step number 4. In step number 4, what we do, we try to locate this value of the test statistics, which is test statistics minus 1.58. We have computed this from the step number 3 in this normal distribution, right? I have plotted a normal curve exactly in the middle. I have taken a mean value and 3 standard deviation on the right side and the 3 standard deviation on the left side. So what we do now, we try to locate this value in this curve. Minus 1.58 minus 1.58 will be somewhere here, right? This is somewhere here. Once you have located this value, you build a wall like this. So this is the value of a test statistic. This is the value minus 1.58, right? And recall from our earlier discussion, if we have a left tail test, then the p-value is the area to the left of the test statistics, right? Recall from my earlier video, I discussed this idea completely here. Well, what is the p-value when we have a left tail test? So when we have a left tail test, the p-value is the area to the left of the test statistics. So this is the p-value, right? This is the p-value. So in step number 4, what we do, we try to find the p-value for the probability value. And what is the p-value? I told you this is the area to the left of the test statistics, left of the test statistics. So in order to find the p-value, we will use Microsoft Excel. So let's see how I compute that. So I'm already in Excel. So what we do, how we insert the formula here. Let's see, we go to the formulas, we go to the more function, we go to the statistical, and the command and the function is t.dist. So we have t.dist. This is the formula, t.dist. Now he is asking what is the x value, right? What is the t value? It's minus 1.58. He is asking for the degrees of freedom. Remember, the degrees of freedom is always 1 less than the sample size, n minus 1. Our n was 10, 10 minus 1 is 9. And in the next step, he is asking, are you looking the cumulative area all the way from the left side to the value of the test statistics? This is usually what we do, and you write a true here. When we write a true here, and when we press OK, the value of the value comes here, and that's the area. That's the area, and that's the p-value, right? That's the area, or that's the p-value. Let me show you what is the exact formula look like. Formula text. Let me write a formula here for you so that you know what I'm talking about. What the formula look like. Look like this is the formula, my dear. T.dist. Give me the value of the test statistics, give me the degrees of freedom, or are you looking the cumulative area all the way from the left of the test statistic? You write a true here and you get this p-value using a t-distribution. I hope you understand that. So the p-value comes out to be 0.0743, right? So this is the p-value, the probability value we have found. Now what we do the step number 5. And what we do in step number 5, we compare this p-value with alpha. Recall our p-value, let me write once again, is 0.0743, and write the value of alpha. It's 0.01. Our alpha value happens to be 0.01, right? Now you compare these two values. You compare 0, 0, 0, 0, and a 7 and a 1. So this number, the p-value is larger. So the p-value is larger than alpha. So with what we note that the p-value is greater than alpha. So what happened in this case, when the p-value is greater than alpha, we fail to reject the null hypothesis. If the p-value is high, H0 must fly. So as p-value is greater than alpha, we fail to reject fail to reject the H sub 0. We fail to reject the null hypothesis, and as a result, we fail to support an alternative hypothesis. We fail to support alternative hypothesis. What was an alternative hypothesis? This one. We failed to support that. We were not in a position to support that the Kaynes are underfilled, right? So at a 5% significance level, now we are going to give some interpretation. Let's interpret that at 1% at 1% significance level. At 1% significance level we fail to support that Kaynes are underfilled. We can't support that, right? So I hope you understand this example and you are able to do that. Now what I'm going to do, I'm going to solve the same problem by using a technology called StatCrunch. Let's see how I do in StatCrunch. So I'm already in StatCrunch, and we go to stat. We go to the, not the ZStat, but a TStat. One sample with summary or with data. We have with summary. Are you performing the hypothesis test? Yes, I'm performing a hypothesis test. So check this. What was the sample mean? It was 11.9. What was the sample standard deviation? It was 0.2, I think. So sample size was 10. And the null hypothesis was that the Kaynes have 12 ounces. And we were assuming they were, the alternative hypothesis is less than. And the significance level is different now. The significance level was 0.01. So this is 1% significance level, right? So I selected this. Do you want a p-value plot? Yes, I want a p-value plot. So let's see what comes up. Here we go. And look at that. We have the value of the t-stats minus 1.58. Look at the value of the p-value reported to us. It's the same thing. Look at our null hypothesis. Look at our alternative hypothesis, and look at that. This is the t distribution with the 9 degrees of freedom. You have t-stats with the minus 1.5, same value on the p-value, and this picture is also given to you. And you can see as the p-value is greater than alpha. Alpha was 0.01. So we failed to reject the null hypothesis. So I hope you understand this, and thanks for watching.